All right. Hey, there we go. I never get used to that voice of God thing going on. So, good morning. Welcome to Django 101. I'm Kenneth Love. You can find me on pretty much any site that has usernames as Kenneth Love. But Twitter's your best bet if you actually want to chat with me. So, I teach Python, Django, Flask, all sorts of other things at Treehouse. We're an online school for learning programming. So if you want to pick up a lot of things, iOS, front end, whatever, you can check us out at teamtreehouse.com. I'm in the middle of writing a book for No Starch Press, which really means I'm way behind because that's how books work. And I'm also a co-organizer for Django Girls Portland. We did an event yesterday that was pretty awesome. So if you don't know about Django Girls, check them out. They're really cool, assuming you identify as a woman. If you don't, it's a little bit more challenging. I really like PyCon, so I'm happy to be here. The cool thing about having people always take videos of you is you get to use yourself as GIFs. Highly recommend it. So this tutorial is a little different. It's meant to be heavily Q&A driven. So I want you all to ask me questions all along the way. You can stop me, ask a question, I'll do my best to answer it. When you're happy, we'll move on. You'll see this symbol a whole lot of places in the talk. That basically means now is a really great chance to come up with questions. If you don't come up with questions, we might be done a little early. So ask me questions. If we don't get through everything, that's cool. You can always ask me things on Twitter. You can look online. You can go to Code Newbie, which if you don't know about Code Newbie, they're a pretty awesome online community for beginners, or anyone really, but they're focused on beginners. So try them out. This is really meant to be a high-level, like 30,000-foot view of Django. We're not going to get into nitty-gritty details of like, you run exactly this function in this way. But you're going to know by the end of this all the bits and pieces that Django has and what you would go customize to achieve the effects that you want Django to do. Because Django's large, Django's huge, and there's tons of moving parts that interact in their own special little ways. So lots of times you end up brute forcing a solution. I really want it to act this way, and you go do that in the view or the template, and there's much better places to do that. So ideally, at the end of this tutorial, you'll have a really good idea of how to achieve the special effects that you want Django to do for you. Which means that it's fairly hands-off. There's not going to be really code for all of you to write, but you'll get to take lots of notes. You'll see probably a little bit of code. I know there's some in the slides. And if we have to, we can totally go in and start playing with stuff in an actual Django project. A lot of the code will also be pseudocode. The handy thing about that is it still looks like Python, so you'll be able to follow along. Okay, so if you're brand new to Django or to web frameworks, web apps, Django is a framework for building web apps. Really what it means is that Django just gives you a whole bunch of tools. It gives you a really strong scaffold that you can use to build your apps. So you don't have to go and figure out how to do SQL in a fairly abstract way. You don't have to figure out how to create forms for user input or validating data. You don't have to figure out how to render templates. Django handles all of that stuff for you, so you really just build the specific business logic that your app needs. All right. Django also comes from the publishing world. It was created at a newspaper. A lot of that still kind of lives on in Django, which is kind of neat, but at the same time, it does influence how you do a few things. Okay, so let's talk about the large land masses of Django, right? 30,000 feet, you just see big stuff. These are the things that you're going to hear everybody talking about. And they're probably the places you've already seen. You've already looked at this stuff. But we'll go over them real quickly, just so everybody's familiar with them. The first one is the ORM, or the ORM, which is fun to say. It's an object relational mapper, which is a program jargony way to say that it takes database records and turns them into Python objects, or Python objects and turns them into database records. It just moves things around, relates them to each other. If you're used to MVC, Model View Controller, this is the M, or model. All right? Forms are another large part of Django. They kind of serve two purposes. They give you a really fast, easy way to create HTML input for users to use to give you data. So you get input fields and text areas and all of those bits and pieces that you're used to seeing in a web app. A better use for them, at least in my opinion, or a more interesting use, is that you can use them to validate any data that you want. So somebody gives you a giant blob of JSON, or you get something from a CSV file, or you've read a text file off of the hard drive. You can send it into a form and make sure that it actually fits the data that you want it to have, the format you want it to have, which is really awesome. You don't have to write your own validators. Templates, which are flat text files, they get mashed together with variables, context processors, all this other stuff, and they generate a single output file. Usually that file is HTML. It doesn't have to be. You can generate XML, SVGs, PDFs, images, whatever you want to generate. In other frameworks, this is the V part. This is the views. But in Django, they're templates because this is the web. We have templates in like every other language and framework, right? And then we have views. Views handle the transition between HTTP requests and HTTP responses. So a request comes in, views do stuff, a response goes out. In other frameworks, this is controllers, the C part. So in Django, we have MTV instead of MVC. It's a little weird talking to people from other frameworks and languages, but you get used to it. It's not that bad. MTV, Model Template View, instead of Model View Controller. You'll usually hear MVT because people don't want to say MTV because it sounds silly. But if you're going to keep the letters in the right order, because views become templates and controllers become views. And it's really weird till you get used to it. And then you go to another framework and you're like, yeah, I'm going to go make a view. And they're like, why are you making a view? You need to make a controller. Because Django. And then there's the admin, which is like, when I first started doing Django, I had been building PHP stuff for a long time. I'd been building CMSs for casinos in Vegas. Not the most glamorous job. And found Django, found the admin, and it was like, oh my god, I never have to make a CMS again. This is so awesome. It's a little dated now as far as like other frameworks have similar things where it'll turn your models into interfaces for you to use, but Django's admin is still pretty amazing. You can do a huge amount of customization. It has a lot of features right out of the box. And it can go a long, long way. So, highly recommend it. Okay, so in Django, we have projects and we have apps. Sometimes these two words are a little weird for people when they first get into Django. So let's talk about what each of these is. So a Django project is your whole entire web app. It's your website or whatever. It's the whole big thing. It's all the little bits and pieces of Django, third-party packages, everything you've written, all coming together into one thing. When you look at it in code, though, this is kind of what I mean by a project. So we have a project here called Dieter. It has a SQLite 3 database hanging out in it because I'm doing development on it. There's a folder called Dieter inside of that, which is like a little stub app. It looks like an app, but it has no models, it has no views, and it doesn't work like an app. Inside of there, though, is my settings, my site-wide URLs, my whisgy.py, which we'll talk about what that is in a minute, and my manage.py, which lets me run management commands. So this would be my project. Inside that same outside Dieter directory is where my apps also live. So apps are just one piece of your project. They're generally a single idea in your app, and usually your app has a major model to it. It has one model that you really focus on. So maybe you're doing the Dieter thing, and this app is going to talk about meals that people eat, so you can track calories and things. So your main model might be called meal, so your app is probably called meals, Typically, the app name is the pluralized version of the major model in the app. That makes it really, makes it really easy to talk about how things relate to each other. And your apps end up looking like this, right? You've got a handful of files and directories that control like the admin, the app registry, your model migrations, your models, your templates, your tests, and your views. So why do you break things up into a new app? The reason you break things up into an app, it's usually about the models, like I kind of already talked about. If you find yourself making a ton of models, then that's probably the time where you need to step back, reevaluate, and decide if you need a new app or not. It's kind of that way for a lot of Python, right? If you find yourself writing a ton of functions into a file, maybe it's time to think about making a class or breaking those up into other modules full of functions. If you find yourself making a lot of classes, maybe it's time to think about having abstract classes that they can all inherit from. So it works the same idea, only it's multiple files instead of lines within a file. So for example, maybe I have these 5 models. Would it make sense to break these up into a couple of apps? Probably. Put the top 3, the bold 3 into one app, and the italic 2 into another app. Okay, so before I get into nitty-gritty details of anything, any questions over kind of the large overview of Django? Better described by model? Yeah, so a model in the code sense is a description of some data. So I might have a model that doesn't relate to a database, right? But a model is like, how do I describe a thing? It's effectively just a class, just an object. So if I'm describing a car, then I get like make, model, year, stuff like that. That could be a model that goes into the database for holding on to the data. Or it could be something I'm just holding on to as information somewhere. The idea is just that I'm creating a code construct that represents a thing I need to remember or to work on. So really, there's not a difference between them and classes that you'd use in a non-Django app. They just go to a database, usually.
Yeah, usually models are always the database, and then it's like a table in the database. So what you're saying doesn't have to be in the database.
Yeah, you can have models that don't go to the database. We will talk about those in a moment. They're called abstract models. Yeah, most of the time it does. Most of the time it is in the database. Most of the time a model represents a single database table, and the attributes on the model represent columns on the table. Okay. So let's talk about models and the ORM. So models are classes. They relate pretty closely to database tables. Occasionally they don't. We'll talk about why in a moment. And their fields represent columns in a table. Each record is a row in the table. Now Django's models come with a couple of extra special things, like you don't have to specify the primary key field or the ID field of a model. Django will do that automatically for you. Django will handle setting up a lot of indexes for you, unique together constraints, uniqueness constraints, things like that. You just tell it you want them. Django handles writing all that into the database for you. So you get to save yourself a lot of time as far as the nitty-gritty details. For instance, though, if you were to switch to, say, SQL Alchemy's ORM instead of Django's ORM, some of that changes. You have to write those rules yourself. I highly recommend sticking with Django's ORM. So you have things in the database. You need to get things out of the database or put new things into it or change things that are in it or just find things that are in there. That's where queries come in, which is kind of the other half of the ORM. On one side we have models, on the other side we have queries. Queries let us manipulate the database in whatever way that we want. So for instance, if we have an exercise, recipe, and ingredient models, then we could create one or filter on them to find ones that match criteria, or we could delete some of them. So if I'm creating an exercise object, then if my columns, my attributes, are name, description, duration, difficulty, and intensity, I just send in those things as kwargs to Django. Django translates all that to SQL, sends it to the database, and since I'm using create, actually gives me back the record that was created, assuming everything went okay. Now, there might be other fields that I haven't listed here that are optional fields. They're not required, but I have to give all the required fields. That's why they're required. And you notice I don't have to create, like, I don't have to send the ID through. I don't have to know which exercise this is. Django handles that automatically for me with an auto-incrementing field. Or if I'm going to filter, then I can pull things out of the database. So one of the nice things about Django's querying ability, it actually has this whole like domain-specific language almost for querying, where you can use double underscores to represent either jumps through the database from one model to another, or as filters on data that's in a field. So for instance, the bottom two lines, cook time double underscore LTE equals 60, or prep time double underscore LTE equals 15, says to find something where the cook time is less than or equal to 60, and the prep time is less than or equal to 15. 150? What? 15. On the top one, though, it's a bit more complicated, and we'll talk about what more this means in just a moment. But to read the line out, it's looking for a related model called ingredients that's related to another model named ingredient that has a field named name, which contains case insensitive, which is what the I stands for, the word spinach. So I want to find a recipe that has an ingredient in it with spinach in the name that takes 60 minutes or less to cook and 15 minutes or less to prep. It's a lot of work that Django does for you. You don't have to do all this yourself. The cool thing about this is it does like subqueries and select intos and all that stuff where you don't have to do that yourself, which is nice. So did you notice that all the queries I showed had a thing in it, .objects? I'll go back and point it out. Recipe.objects. So .objects is what's called a model manager. So model manager gives you all the ways that you're able to use the database. So the methods we were using, filter, get, delete, create, all of those live on the model manager. So the model manager knows how to turn those things into SQL and give you back the results. What's really cool is you can create your own model managers. So you find yourself constantly pulling out blog posts that are already published, or you constantly find yourself pulling up avatars that have a size over 512 or whatever. You can make model manager methods to find those things for you automatically without you having to write those queries over and over and over again. So they're really handy. Another thing you can build that ties into model managers but isn't as common is called a query set. All of the queries that we did will return a query set, but you can create pre-filtered query sets that are just available for you whenever you need them. You won't use them a whole lot. Check the docs if you ever find a case where you're like, I have to have this all the time. That's when you probably want a query set. Okay. Models and ORM, querying, any questions on that area? Yeah.
Do you have to use that special language with the double underscores, or is there, another way to do less than and greater than?
So do you have to use the DSL for querying? Pretty much. I mean, so you could pull all the records out and then filter them yourself through, functional programming or if conditions or whatever. But as far as Django's ORM is concerned, you'll use those or you'll use raw SQL. You can send through raw SQL. There's not much point in having an ORM if you're constantly sending through raw SQL, other than it's a database abstraction. Yeah.
How do you extend your models easily?
Like,
So custom fields, like with functions.
okay, it's like a custom user model. Okay. I don't think I actually covered that. So you can
I've used backbone and extending models using it that way with Django PyCon. I was wondering if there's now a way where you can easier do that with Django.
So Django since 1.5 has offered custom user models. where you, instead of using Django.contrib.auths models, you can use your own custom user model. You define an entirely new model, you specify all the fields that you want, everything. It's a bit more work, it's a bit more complicated, but it's totally, possible and doable. And it all ties in really nicely. Because of that, they added in methods for like get user model and stuff like that, where you don't even have to worry about third-party packages. So long as they're using that, they'll find your user model and everything will be fine. Depending on what you want to do, it might be better just to make a new model that's associated with the user model, but that kind of comes down to whatever your design is of your data. We're going to get to some of that in just a minute with inheritance. Anyone else? Okay. Let's talk about inheritance. So if you've done some Python, then you're probably used to the idea of like classes inheriting from each other. A lot of your classes inherit from object, or you have, an animal model and then cat and dog extend that, to use like the worst inheritance example ever. Django models have a similar idea of inheritance, but we're dealing with the database, so inheritance has to involve database tables. So there's two kinds that get used. Well, there's only two kinds. The first is multi-table inheritance, or MTI. You're at PyCon, walk around to some of the other people that do Django and ask them what they think of MTI, and they'll probably all tell you they hate it, with fairly good reason. So MTI creates a new table for every model that's part of the chain. And there's an invisible connection between the two models, which means that quite often you're doing extra queries you didn't think you were going to do. So as an example, we have a message model that has 3 fields: created at, created by, and content, whatever the content is of the message. And then we have 2 special types of messages. We have an email and we have an SMS. They both extend message. Email adds a to-address field, and SMS adds a to-number field, because you want to send the SMS to a number and send the email to an address, right? So this is okay. But in the database, you now have 3 tables. You have a message table, an email table, and an SMS table. And when you go and fetch an SMS, you go pull one out of the database, you're going to want to do a query that actually goes back and gets the message as well, because it's a different table and a different row. So you're always doing 2 queries to move your way between them. And if all you have is a message, you went and selected a message, you have to do has attr, has attr, to find out if it's an email or an SMS message, like which one it's related to. So it becomes kind of a pain to find all of these bits and pieces, and you end up doing an extra query that maybe you didn't expect to do. That's not a big deal unless maybe you have, 10,000 SMS messages that you're looking through. Then it becomes kind of annoying. The connection between the 2 of those is called a one-to-one field, and we'll talk about more about those in just a moment. The other type of inheritance we have is abstract, and I was especially proud of that icon. So abstract inheritance, unlike MTI, is kind of awesome. Nobody that I know hates it, and it doesn't create extra tables. So it only creates the tables that are the actual final concrete models that exist in your app. So let's look at this thing again, but as an abstract model. So the difference here is we added this class meta and abstract equals true, which marks that model as being abstract. So message never exists in the database. It's nowhere in the database. Email and SMS both get all the fields that message has. So when you define their models, they're much smaller. You are just thinking about the problem they solve, their problem space. But they still get all the fields that message has, so that you have all of the content you actually want. So you'll never be able to query for message, but you can query for email or SMS, and you don't have to go back to another table to get out the message that they belong to. So it makes your design a little cleaner inside of your models.py, and it makes your database a lot cleaner because there's fewer tables. You should all know what this means by now. The inheritance isn't that weird. It's only 2 kinds. It's fairly easy to get used to. MTI does have a few occasional really good uses, but you'll know them when you find them because it'll be the one place where you're like, yeah, I do need all these tables. Most of the time, you're just going to want abstract if you need inheritance. All right. Yeah? Mm-hmm.
With the original model, if you add a field to the base class, changing one table. With the new model, the abstract model that you've got, how easy is it for you to modify a base class? Because if you do so, you're going to have to modify all of the abstract classes too, the derived classes as well.
Right. So the question is, with MTI, and you were to go change the base class, the message class, you would change one table in the database. And with abstract, you would end up changing however many child classes there are, all those child tables. So Django's migrations framework can handle that really well. Like it knows how to do that. It'll create all the SQL for you and run through it. How expensive that will be is going to depend on how complicated your tables are, how many rows you have, what database you're using, all that kind of stuff. Which that ends up being the same idea on MTI as well, because you are going to have, so if you've got 5 derived child classes that do MTI, you're going to have 5 times as many records inside the message class, inside that base class, because it has to have a record for all of those child records. So it's kind of just distributing it, right? Like you're either doing all the work on one table, but way more rows, or you're doing the work on more tables, but fewer rows. I don't know that one's better or worse. It's really going to come down to your own system. So let's talk about relationships. So we've had foreign keys and things like that. Actually, let me show if I can get to it. Haha, I can. But now I have to try to use a model or a screen I can't see very well. Okay, so let's look at, say, this field or this model here. Can you all see that well enough? Can I close that and then bump up the font? Okay. So recipe ingredient here. You see we have these foreign keys that go off to recipe and have related names. So these are what we're talking about when we talk about relationships. So, okay. Let's talk about foreign keys. So foreign keys are a way to relate one record to another record. Often these cross tables, so you'll have a message related to a user, but they don't have to be. It can be a message related to a message. So foreign keys, depending on which side of a foreign key you're on, can be called a many-to-one or a one-to-many, because it just depends on which side you start. So, for example, and you'll have to ignore a little bit of astronomy here, if you had a star instance, it could have many planet instances that were attached to it, but each planet instance would only have one star that it's attached to, right? So we ignore binary, trinary stars, all that stuff. So that's the idea. If I'm a planet, then I have many, or I have one star. And if I'm a star, I have many planets. In other frameworks, languages, you'll actually hear these called has many or has one, as opposed to foreign keys. Your database usually has foreign keys built in as an actual thing, an actual construct. Django takes advantage of those. It gives you faster performance most of the time. Not every database does, and you won't want to use that every time. But that's way beyond the scope of this talk. So one neat thing about foreign keys in Django is this thing here called related name. So related names are for the many side. So what would the many side call this thing? So if I'm on a recipe ingredient, or sorry, what would the one side call this thing? If I'm on the recipe that the recipe ingredient is linked to, the recipe ingredient would call all of these ingredients ingredients. And if I'm on the ingredient side is going to call all the recipes recipe, because that's what they belong to, right? So the foreign key helps you, the related name rather, helps you make your API for dealing with your models a bit more human readable, a bit more understandable. Yeah.
The recipe was plural in the related name for the.
Right.
Did you? Yeah, for ingredient.
Right, because if I'm on, so we'll talk about what kind of table this is in just a second. This is a special kind of table for a different kind of relationship. but the foreign keys still work like foreign keys. So if I'm on the ingredient, this is my path back to the actual recipe it belongs to. One ingredient could be in multiple recipes, right? I can have 100 recipes that all use apples. So if I'm on an apple, I want to be able to go, well, what are the recipes that apples belong to? So that's why the related name is plural. Your related names are pretty much always going to be plural, unless you have like a word that doesn't pluralize without changing. So don't model, like moose. Okay, so one-to-ones are foreign keys that are unique. So if one thing can only ever belong to one other thing, they have to belong to each other, those are one-to-ones. So for example, if you have a user, and a user has a profile because you want some extra fields for that user, that one user is ever going to have one profile, and that one profile is only ever going to have one user. So this is known as a one-to-one relationship. The cool thing about one-to-ones is Django makes them basically automatically available to each other. So if I'm looking at the user, I can do like user.profile.height, and I can get their height that they entered into the database. If I'm on the profile, I can do profile.user.username and get their username. These are foreign keys. It does require another select or another SQL thing, but they're pretty awesome. This was the way that you always did extra data for users before Django had custom user models. For a lot of us, this is still the way you do extra user things because it just seems easier to me. I've been in Django too long, I guess, but it seems easier. Yeah.
Is it lazy evaluations if you have profile.user and user.profile?
Yeah.
Actually go out to the database and get that information when you load the parent or when you ask for it.
It'll do it when you ask for it. It's lazily loaded. It doesn't go back to the database until you need it. We'll talk in a minute about how to make sure it gets it beforehand, because often you do want to have that available right away, especially if you can get it in a single query, which you usually can. Yes? I can't hear you. Can you say that a little louder?
So if we define the relation in Django,
Mm-hmm.
then we are not allowed to directly access database to change the relationship by SQL directly, right?
So Django doesn't lock you out of changing your database with SQL. You could totally go in and change it and really mess up your data. Generally, the idea is you want to have like one interface for these things, right? So if I'm handling my database through Django, I want to do most of my database work through Django. I would rarely want to go in and change anything in raw SQL unless it was like performance related, or I had to do a really complicated migration of data that maybe Django's migration framework couldn't handle, which I've never seen one of those, but I'm sure they exist. But yeah, Django doesn't stop you from actually accessing the data. I mean, you can log into your database, run whatever SQL you want to run. I suggest you don't, but you totally can. Okay, and then there's many-to-many. So many-to-many is kind of just a hidden double foreign key, but the idea is that you have multiple instances that can relate to multiple other instances, right? So a recipe can have a whole lot of ingredients, and one ingredient can be in a whole lot of recipes. So these are a many-to-many. Django automatically creates for you what's called a through table. So it's another table that has a foreign key off to each thing. So when you go, yeah, I've got a recipe, give me all the ingredients, it goes through that through table, hence the name, and gets all the ingredients. And vice versa going the other way. You can customize the through table if you want, like I showed in that example, by making your own table. And you can tell Django about it, or you can not tell Django that there's actually a many-to-many, and you can just query that through table and go get the stuff you want. So the custom through tables are where you put extra data that you need for whatever your model is. So if a lot of users can contribute to a blog post, so you have authors and blog posts as a many-to-many, but you want to know when each author was added, you'd put like a created at timestamp on the through table, write your own custom through table, and now you've got that data. There's one other kind of connection, and I'm actually a little worried about telling everybody about this one. It's called a generic foreign key. So a foreign key always relates to another model, right? And I have to know what model it relates to. My blog posts relate to an author, to a model. If I don't know what it's going to go to, though, I can make what's called a generic foreign key. Generic foreign key is actually a double foreign key as well. One goes off to the content type framework, which is basically just a list Django has of all your different model types. And the other one has an ID number for the thing it's actually going to. So we're like, OK, it's a recipe, and it's number 3. So that's the GFK. GFKs are not very performant. They take a long time to look up a lot of this stuff. Usually you're better off creating more models. Yeah. Through the which part? The looking up all the models, or?
Trying to connect where it will go, or is it just a general purpose?
It's pretty basic. Whenever you register an app with Django, or when Django sees your models, right, and you create your migrations, it always puts a record into a table that's called Django_content type. And so each one of those has an ID, and it has whatever your model name is. So your model name is recipe or user or whatever, right? So then when you do the GFK, it's like, OK, pick the model that it belongs to, user, and it stores 2. And then what user is it? OK, it's user 10. So we get 2 records for the GFK, which one is 2 and one is 10, and it just goes and looks that up every time. Yeah, it's literally just using foreign keys against the database, which is why they're not super performant. You have to go do a lot of lookups. You have to go find all of these content types, figure out which one it is. Then once you find out that it's user, you have to go to the user table and get the user that it actually is. So stay away from GFKs if you can. Don't tell anybody I told you about them. Don't use them. Just stay away. They do have a couple of legitimate uses. If you're building a third-party reusable app that you want people to install and use, and you have models that they need to be able to associate their own stuff with, or with their own stuff, GFKs are kind of your only solution, other than storing config data all the time. So again, when you get to the point where you need it, you'll kind of feel that you need it and realize that's the thing to use, but avoid them as much as you can. It's weird telling people to avoid things. Okay, anything else on relationships? Okay, they're not too weird. But often you have to do a lot of queries for your relationships, right? We've talked about how foreign keys, you have to go get another table. Generic foreign keys, you got to go get at least 2 other tables. There's a lot of database selecting that's required. So there are ways to make that database selecting less painful, because you don't want to hit your database more often than you have to. Excuse me. The first one's called select related. This one comes first because it's oldest. It's been there for a long time. Select related is really handy, and it lets you go and select a related record or related records. So if you're on the model that doesn't have the foreign key, so if I'm on the user and I want to get their one-to-one profile, or I'm on a user and I want to get all their blog posts because the blog post has the foreign key back, user has no foreign key, then I can use select related to go and get all the blog posts. It looks something like this. So I have my recipe thing that I'm dealing with. I want to go and get ingredients, and I want to go and get the ingredient that's linked to all the ingredients. So you can still traverse relationships inside select related. So ingredients, _ingredient. And what this will do is in a single query that may have some subqueries, but a single ultimate query, Django will go and get the recipe objects that I'm looking for, and all of the intermediate through table objects, and all of the ultimate ingredient objects that we're looking for. So I get all those things back as one giant SQL blob, which then gets turned into models. So I did one query, which is pretty cool. The opposite of this is prefetch related. I wish they were named a little more distinctly, but they're OK. So if you're on the side that has the foreign key, So if I'm on the blog post and it has the author somewhere, then I can do prefetch on the author to go and select them as well. But Django's going to do this through two queries, one to the blog post that I'm on and one to the author table. And it's going to put them together for me before it gives them to me in Python. So that ends up looking like this. I'm on the recipe ingredients, which has the foreign keys that go off. Go and prefetch the ingredient, go and prefetch the recipe, and then give me back all these things that have spinach in their name. All those will come back. As far as I'm concerned, as a programmer, I never know that multiple queries happened or that Python combined things or whatever. It's just available to me as this new thing. Yeah.
So what's the difference between the prefetch and the related?
So under the hood, the difference between them, prefetch related is handled all in Python, and select related is handled all in SQL. As much as possible on both sides. But yeah, you want to do as much in SQL as you possibly can. But if you can't, then that's cool. Python will handle it. Any other questions on pulling stuff out? If you are worried about database speed, all those places that you did foreign keys are really good places to put indexes. Yeah.
So you could use prefetches if you've got excuse me, if you've got data entered, but it hasn't used the database and do whatever manipulation on it before it's in the database, then I guess using Python. Just trying to think of when you would use that.
So prefetch and select related are more for stuff coming out, like to a view to be displayed, rather than data going into the database. You could, I suppose, select something before you entered a new record, like if you had to relate things. But you're still pulling something out of the database, right? So you wouldn't use select related or prefetch related when you're doing, like, say, .create or .save. But you would always use it for .get, .filter, .exclude, the other things that give you query sets back. Okay, anyone else about selecting stuff? I forgot what my basket icon meant. Okay, so when you're dealing with SQL, you're dealing with queries, fetching, all this stuff. It gets slow sometimes, yeah? Or you find pages that suddenly take a minute and a half to render. Django debug toolbar. If you don't know about this package is amazing. You basically pip install, I think it's just debug toolbar, and you add it to your installed apps. It shows up as a little tab on all your pages, and it will tell you how many SQL queries ran, how long they took, how many of them were repeated, so you can go try to collapse those into a single query. It tells you templates that didn't work, or signals that got fired, or how much time you spent in the CPU. It will literally display as much information as you would want to help you make your pages, make your views, make everything better. So this should be like the second thing you ever install. You install Django, you install debug toolbar, because it's really good. And I think I actually have an example of that. Let's find out. I can't type on screen. Sorry. This thing's being weird. Cool. So here's the debug toolbar. And this page is just showing, one recipe with a couple of things. But if I look at the SQL here, I can see that I did a select from meals recipe, a select from meals recipe ingredient, a select from meals ingredient, and a select from meals preparation. I can use select relateds, prefetch related, stuff like that on here to try to make that a lot more manageable. Sure, I only spent, what is that, about 1 second, 1.2 seconds in actual time. But if I don't have to spend that time, why spend it? It'd be better to spend half a second than a second. There's all the other stuff too, which is all cool. Okay, so something actually that you might see this thing here called signals? Let's talk about what signals are. So signals are kind of awesome. They're kind of like webhooks or callbacks for other languages. So you do something in Django. You render a template. You find a URL. I'm trying to remember what all the signals are. You save a model instance. We'll go with that one. I know that one exists. Django sends out a signal saying, hey, this model instance was saved, and here's the model instance that was saved. And you can register listeners for these signals. So you have a created user signal that listens for when the user model is created. And when a user model is created, it creates a profile model, because you want that one-to-one to work, right? You want these two things to exist. So it automatically creates that, and maybe it sets filled in equals false, so the user is immediately redirected to a page to fill in their profile. So signals are pretty awesome. You can use them to listen to a whole bunch of stuff, and it's a really great way to add a bit more responsiveness to your apps. Thankfully, they don't have callback hell. You're not spending like 4,000 callbacks and having to resolve each one of them. You just have however many are registered, and they just all listen. All right, and we're just about up to break, so let's see if there's any questions on ORM model stuff, and then we'll go do the break. Anybody? Anything else on ORMs? No? Okay, cool. So we have a break for a few minutes right outside in that lobby. So we'll say back in 10 minutes. There's snacks, coffee, stuff like that. And I'll turn off my mic. All right, everybody have a good break. Get some sugar and some snacks. All right, so let's talk about forms. Forms are pretty cool, actually. So if you missed the beginning, forms are a handy way of getting information from a user and then making sure it's good data. And depending on the type of form you're using, then like creating a database table from, or a record from it, or doing something else. So we have two types of forms in Django. We have standard forms, which are, it's a form. They don't tie to a database table. They don't represent a model. They're completely free form. You can put whatever fields into this that you want. And Django comes with a pretty large collection of fields and widgets. So like the difference between having input type equals number and input type equals text is the widget. And these are really handy when you're validating external data. Or you have a form, like maybe you have a contact form that you want to actually have send an email because, you're replicating a PHP site from 1999 and you just want to have somebody email you. Standard forms are awesome for that. Again, these are cool, though, for validating data because you can build up the form, you can toss the data into the form, check if the form is valid, and if it is, all the data matches the schema that you wanted it to match. So that's pretty cool. Lots of times, though, you're going to be making a form because you want to edit or create new database records, new model instances. Instead of doing that manually, you can use model forms. Model forms are really cool. You give it a class name, you inherit from model form, and then you tell it what model it relates to, and Django does all the rest. Django creates all the inputs you need for the different model field types that you have. Django knows how to save things. If you give it an instance for the model field, Django pulls that instance in, gives you all those values already pre-filled into the fields, and you can edit them, and then it just saves them. So that's all pretty cool. If you've played around with model validation a little bit, and we'll talk more about validation in a second, then you know that models have a clean method that you can use to like verify the data in the model. Model forms don't call that, so don't put too much into your model.clean. But we'll get to that in a second. So validation. Fields in forms automatically know how to tell if their data is the correct type. So if you have an integer field, it knows not to accept a string, right? It knows not to accept a float. It knows to only accept an integer. URL fields know how to tell if something's a URL. So fields already have built-in validation that covers 99% of your use cases. Sometimes, though, you want to customize your validation. So you have a lot of options here. Let's talk about what those are. The first one, and the broadest one, really, is form.clean. Every form has a clean method. This method is called after all of the other steps of validation are done. This is the very final step of validation, which means that you have access to all of the already validated data when you get to this step. So if you need to make sure that two fields work together, like password and verify password, right? Making sure they typed in the same password 2 times, then form.clean is where you handle that. And everything I talk about in validation here applies to model forms and forms. I'm just going to use form because it's one word instead of 2. So form.clean is like your final last step. Before form.clean happens, though, is clean and then a field name. So I want to clean the message field and make sure there's no profanity in it. So I can do clean underscore message and then check through whatever content they gave me for that field. So yeah, or I'm going to let them do a rating. I want to make sure that rating is between 1 and 5. So in clean underscore rating, if it's anything above 5, I kick it back out. You raise what's called a validation error, which comes from the forms library. You give them a message, and it appears above the form as non-field errors. Actually, no, that'd be field errors. Yeah. You can also apply validators to a field. Django comes with a whole bunch of built-in validators. There's validators for like making sure the input matches a regex, making sure it's above a minimum value or below a maximum value. You can also write your own, though, which is kind of cool. They're really just like a function that takes a value. You check to see if the value is whatever you want the value to be, and you either return the value or you raise an error. The really cool thing about validators, though, they live wherever you want them to live. So validators.py or your forms.py or whatever. But validators can be used on model fields directly as well. So you can have it validate on the form level and on the model level if you think sometimes you may be creating model instances without a form. So pretty handy to be able to reuse these things in multiple places. Of course, if you just put it on the model, the form will hit that too. So. And then there's the model clean, like I said. So model clean is run only when you use modelform.clean. So model forms will run model.clean. Models do not run it themselves, which is really weird. Used to bite me all the time. There's also a model.fullClean. The only thing that adds is it does uniqueness checks. So if you're like, hey, I want to make sure that the email address and the phone number are unique together. We can't have more than one account that has the same email address and phone number. Then that's where the uniqueness check comes in, which is checked in model.fullClean. You won't customize model.fullClean or model.clean all that often. Those two are kind of just there if you need them. Okay, anything about cleaning or validation? It's not the most exciting subject until you need it, and then it's so awesome. All right. So now a part I don't like. Has anyone ever played with form sets or know what form sets are? So form sets are a way to have multiple instances of the same form at the same time. So normally if I have a form once, right? I'm entering in one blog post or one tweet or whatever. But maybe I need a way to enter multiple things. Maybe I have a restaurant website where people can come and pre-order their food, or they can order food for catering. And I want them to be able to enter a bunch of people's names and their dietary restrictions and their choice off the menu, right? I don't want to do one form for every single person, like one form per page on every single person, because that's really annoying to use as an end user, right? You don't want to click save 100 times because you have 100 people at your party. So what if I gave the ability to enter 100 people's data all at once? I need 100 forms or 100 copies of my form. So this is where form sets come in. In that use case I just described, form sets are awesome. They're great. We build this form set with 100 things in it, or I can say, hey, give me 10, and if they want more, give them 3 more at a time, whatever I need to do. That's really cool. I can take all those, save them to the database, send off emails, do whatever I need to do with them. Form set validation works just like form validation does, just on scale, because it's a lot of things being cleaned at once instead of a single thing being cleaned. All right, and there's 2 types of form sets. There's form sets and there's model form sets. So it depends on whether or not it's based on a model. Where form sets get tricky and really annoying is one of their supposedly awesome features. It's just never been easy to use, which is known as inline form sets. So maybe I'm taking all of your credit card details and all of your contact details, and I'm taking your 100-person order. So I have a form up here that's holding on to who you are, that you're ordering my stuff, and then I have 100 forms in a form set that are taking the details of all the people ordering food. That form set's called an inline form set because it's in another form. They can be really simple to use, but most of the time they're not. They're just a giant, irritating thing to work your way through. There is one place where inline form sets are awesome, though, which is in the admin. If you create what's called an inline in the admin, it creates inline form sets for you, so you can edit more records in the admin at once. What makes these awesome is the admin does all the work for you. You don't have to do it yourself in your views. So most of the time when I use form sets, yeah, it doesn't end well. Anything about forms or form sets? Hopefully not form sets. All right. There is one other thing in the form library that's got the potential to be really awesome, but the times I've used it, it's not been that great, which is Form Wizard. If you have a really large form, or you have a bunch of forms that need to be filled out in a row, you can set up a Form Wizard, and Django will move from form to form to form and let the user fill them all in and holds on to everything in the session. It's not as convenient as you would like, but it's kind of cool if you want to check it out sometime. All right, so the next major part of Django is templates. So like we talked about, templates are text files that Django renders, smashes them all together into a single file. They have some data that comes in, which we call the context. You'll often hear people talk about passing the context to a view or having a context dictionary, which is really just a dictionary full of keys and values that will get rendered into the template if they're needed. Templates don't have to be HTML. They can be text because you're making emails, or they can be turned into PDFs in the end, or whatever. Django's fully capable of rendering JSON, XML, whatever stuff you want. Sorry, I keep feeling like I'm popping there. Usually, though, if you're going to do JSON or XML, there's better ways of doing it than compiling text templates. Like the JSON library exists. It's a thing. So let's talk about what's in a template. Django templates have 2 kinds of signifiers that go around values that you'll see in templates a lot. They have 2 different meanings. So the ones that have the curly brace and % sign, or mustache and % sign, those are basically calling Python functions. They're executing code. So those will be where you have for loops or if conditions, or you call a function of some kind and its output gets something done with it. The other ones, though, have 2 curly braces, double mustaches. Those are effectively print functions. So you're still calling Python, but you're just calling print. The output, instead of going to standard out, goes to your template. So we have 2 ways of getting power into Django templates. When we're printing, we can also use a filter. Filters always start with a pipe character, and then whatever the filter is. Some filters take input, so you'll have a colon and then some input after that, for whatever the input is. Filters will manipulate your data. So maybe you have a blog post, and you want to make sure that the blog post title is always all lowercase except for the first letter of each word. So you could give it 2 filters. You could give it lower, and you could give it cap first. It'll lowercase it and then capitalize the first letter. You can have one that checks for a number to see if it's divisible by, say, 2, and then you can output whether or not they give you an even number or an odd number. So your template filters let you do little manipulative bits to data only in the template. You're not manipulating the data in the view or in the model. You're only manipulating it for the template. And of course, you can write custom filters, because eventually you're going to want to. You're eventually going to have a blog post that's written all in Markdown, and you want to render it to HTML in the template instead of storing the rendered HTML in the database. You should totally store the rendered HTML in the database. Way better idea. But if you don't want to, there's how you can do it. So custom filters are actually pretty easy to write. They are just a function, and you register it with the template library. The docs that Django has for how to do that are amazing. They're not that bad to do. Or if you prefer video lessons, a friend of mine, Lacey Henschel, created an awesome video tutorial on that. And so the curly brace %sign tags, you can create your own custom tags for those as well. So if you need to do more powerful special things in a template than just sending data to that template, you can create your own custom tags. You can make tags that'll turn a picture into ASCII art or whatever if you want, which would actually be kind of a cool tag. Someone should make that. So let's talk about the couple of types of tags that exist. There are simple tags, which are the simplest version of a custom template tag. They're very well named. Simple tags optionally take an argument. They don't have to take one. And they return something, usually, that gets printed out to the template. As of 1.9, simple tags can now create new values in your context dictionary. Prior to 1.9, they couldn't do that. You had to use what was called an assignment tag. So simple tags have become pretty awesome now. The other type of tag is an inclusion tag. Inclusion tags, if you've used PHP, where you have like the require once, or include directives, where it'll bring in another template into your template that you're currently working on. Inclusion tags are kind of like that. You call this tag, and it renders another template and puts the output of that rendered template into your current template. So, for instance, you have a menu that gets repeated on every page, but you want to be able to highlight the page you're currently on. So you could call the inclusion tag that you built for rendering the menu, tell it what page you're on. It will render your HTML with that page highlighted and put that into your page that you're displaying, into your template that you're displaying. They're really common for stuff like that. They get used for menus like all the time. So they're kind of cool. But do be careful with inclusion tags. If you're rendering something that has to go and hit the database, you just made another database call. So that's where debug toolbar comes in to track all the times that you've hit the database. Okay, anything about tags before I move on? I forgot my question mark slide. So just pretend there's a question mark. No? Okay. So I talked about how templates have a context dictionary that we send to them that's full of data and information that gets rendered on the template. Well, outside of that dictionary, Django provides a whole lot of things that are called context processors. As you can probably guess from the name, they process your context. Usually this means they add things into the context. So for example, one of the ones that's enabled by default is the auth context processor, which makes sure that if you have a user of some kind that's authenticated, that there is a user key in your context that always points to that registered user, to that authenticated user. It points to an anonymous user if they're not logged in, but anonymous users are nowhere near as useful. There's a static template or context processor that always gives you the static URL setting so that you can refer to static files like your CSS or your JavaScript. These are really common that Django provides. You'll use these all the time without even knowing it. I don't think they're even listed in settings.py anymore by default. But you can also create your own context processors if you have a thing that you know you always need to have available in all of your templates. There is an overhead to this, obviously, because a little bit more code that every template has to go through, maybe another database call, maybe, whatever. But they are handy to have around. If anyone finds a really good use for it, let me know. One of those context processors is called the messages context processor. So Django has the ability to send flash messages to users. They have nothing to do with Adobe's technology. They are simply messages that only appear for one page view. So they're stored in the session. They pop up once for users to see, and then on the next page load, they'll be gone. You can send them from your views. You can send them from anywhere that has access to the request object. So if you send request off to a model method, you can send it from there. So flash messages are really handy. and it's also one of the context processors that you'll use a lot. Okay, anything about templates? It's just HTML. It's not the most complicated part of Django. All right, cool. Views. This is probably the biggest subject area because you do a lot of work in views, which is kind of an anti-pattern. Your views should really have as little code in them as possible. Keep your views very small. Put a lot of stuff in your models if you have to put a lot of stuff anywhere. So the way views normally work, or controllers and other frameworks, is an HTTP request comes in, eventually gets to the view, right? The view interacts with the database, calls Python, does whatever it needs to do, and then sends back an HTTP response. So that path is known as the request response cycle. Let's talk about what that is just for a little bit. So the client makes a request. The browser wants, whatever's at /recipes/5. It doesn't know what's there. It doesn't care. It just wants it. So that request comes through and hits your server. Your server goes, well, that's not a static file. It's not CSS or JSON or JavaScript or anything like that. So I'm going to send that off to the WSGI server, the WSGI server, which is Python. That's your WSGI file that's inside of all your projects. That's your gateway, that's what the G stands for, from your outside world into actually Python. So now we're inside Python. We don't care about Apache or Nginx anymore. We don't care about the browser that requested the thing. We're all inside of Python. WSGI.py creates this GET request thing and sends that off to Django. Or sorry, not GET request, a request object. So now that request object that we're hanging on to starts traveling through your middleware. Middleware are called middleware because they're in the middle. So your middleware is actually pretty awesome. It can check for forged requests. It can check for, you want an appending slash. You notice how I asked for recipes 5 and there's no trailing slash there on the end? Django likes trailing slashes. So your middleware will put a trailing slash onto it so that Django knows how to find it. So when it's going in, it goes through two middleware, which are called process request and process view. Process request handles manipulating the URL, and process view handles making sure it's good for the view and manipulating the view if it needs to, like which view it goes to. So then it hits the URLs. You've all seen the URLs, a big long list of regex, right? So we look through all the regex in order from top to bottom, matching the first one that the regex matches. Regex is actually really awesome for doing this. It's very fast. I know there's a lot of people that complain about Django's URLs, but I think they're pretty cool. So at this point, we have a view that it matches, but if the regex pulled out any arguments, like a PK or a username or whatever, those get pulled out as keyword arguments, as kwargs. So we have one that matches. Django sends the request, and those arguments that it found off to the view. If one doesn't match, Django sends a 404, and we just bail out. We're done. So let's assume we got to the view. So we got to the view. We have the request. We have variables that are from the URL. We have all that stuff. The view goes, talks to the models, the managers, the database, renders forms, validates data, does all the things that views do, right? It renders a template, usually, and then sends this back in an HTTP response. So we no longer have a request object. Now we have a response object. They're similar, but the opposite side. We go back out through middleware, but this time we go from the bottom of the middleware stack to the top of the middleware stack. And we go through 3 possible fun functions, which are process exception, which looks for exceptions, process template response, which manipulates the template if it needs to, like gzipping the whole thing, and process response, which sets headers and stuff like that. We get back through WSGI, back to the server, and then we go back to the client. Ideally, this whole thing takes a second or less, right? We want fast web pages. If something blows up between the point where we get to the view and we get back to the middleware on the other side, then we go to a wholly separate set of software, which is known as the exception middleware, and that handles sending out the exception pages. So those pretty yellow 500 pages that you get every once in a while, that's where those come from. Okay, before we go on, anything about request response cycle? It's pretty similar to every other framework out there. They're talking about salad. Okay, so let's talk about what views look like. So you've probably seen views, you've probably written views. Views are just functions, right, in Python. They always take at least one argument, which is the request object that comes in, and then they do whatever they need to do before they send stuff back out. So you've probably seen one kind of like this. If you're really old school in Django, you probably remember instantiating the template object with the template you wanted to render and the context object with a big C of your dictionary of context stuff, and then rendering those things together and getting an unwieldy text file that you sent back out. Now, though, you can just use render, which is a whole lot better. Way better. Function-based views are pretty cool. They're really great for people that are new to Python and new to Django because pretty much everybody can understand a function once you understand some programming. So they're not that bad. If you need to protect them, Django does offer some authentication decorators like the login required one that's there at the top, which means if you're not authenticated, you can't see this view. And URLs for those end up looking kind of like this, right? We get a little URL stub, and we get the function that it relates to. Everyone's seen this, I'm sure. All right, so the other option, though, is to make a class-based view. Has anyone built class-based views? No? A couple of people? OK. So class-based views are pretty cool. They're actually my preferred method of making views. The way that they work is we have a lot of patterns when we make views. We have a lot of things that we do repeatedly, right? We render a form, or we have a form, we fill it full of values that came in from the GET request. If it's valid, we save it to the database, and then we redirect to somewhere else. That's pretty common. Or we want to delete a thing, so we want to show the thing that's going to be deleted, make them confirm they want to delete it, and then we actually delete the thing and send them somewhere else. We have all these patterns. So Django wrapped up all those patterns into a whole bunch of generic class-based views, and you can extend those with your own classes and make them do stuff. So here's what's cool. All the work that's in here, including the stuff that I ellipsed out, is right there. So I got 2 lines of code versus 15 or 20. So it's kind of cool. I don't have to do anything really special. If you start using CVVs, you can cut down your code a lot. But that also means there's a lot of stuff that's hidden from you. So if you're not familiar with them, you can get lost really easily. The docs are really good, so check those out. Registering one of those with a URL is a little bit different. We end up having to call this asView method. But that's kind of cool. It exposes a neat part of Django, which is that all of your views are always just functions, because methods are just functions, right? So ultimately, it's always a function. So you can always treat it kind of the same way in your mind. And you can override asView to control how Django finds that that's a view function. So it's kind of cool. Decorating CBVs aren't super easy. You can't just put a decorator on top of a class. That doesn't work right. Django has a thing called method decorator, where you can decorate a method with whatever decorator you want. So you have a decorator that's calling a decorator. It's a little awkward to use. So thankfully, as of Django 1.9, Django provided some mix-ins to require authentication for your views. One of those is login required. They also have them for permissions being required and user passes a test. I have to brag for a moment. Those came from a package that I wrote, which is called Django Braces. If you want to do a lot of stuff with class-based views and you want a lot of control over class-based views using mix-ins, check out Django Braces. We have stuff in there for like automatically doing select related and filling in certain values in forms and stuff like that. So, cool. Okay, anything about views, function-based, class-based views, mix-ins? All right, cool. How about the admin? Have you all used the admin, or a lot of you at least? Seen the admin before? It's kind of cool. Okay, have any of you had to customize the admin, though? All right, so we'll talk about how to do some of that. So you've seen how to register a model with the admin, right? Like you import your model, you do admin.site.register, and then you put in your model name. You probably created model admin objects, which is a new class. You tell it what model it relates to, and you register it, and you can set attributes in that model admin. So these are some of the more common attributes that you set in that model admin. If you don't know about these, they do some awesome stuff. So let's talk about them for a moment. So fields and exclude are just like on forms. So you tell it what fields to show or what fields to leave off. A really good tip for anywhere that you can use exclude, don't use exclude, because you'll forget about exclude, and then you'll add a new field, and now that field automatically shows up for everyone. You might not want that. So always use fields so that you have to whitelist everything instead of having to blacklist it with exclude. Field sets let you reorganize how your form is laid out in the admin. So maybe I have a really large form, and I want to have 4 or 5 fields that are absolutely important at the very top, and I have several fields that are voluntary, that are optional, and I want to have those at the bottom, and maybe even have those collapsed so that you can't see them right away. You only open it up and fill them in if you need to. So field sets gives you that level of control. Filter horizontal and filter vertical are for handling foreign keys, or more specifically for handling many-to-manys. They give you 2 fields, either on top or bottom or left or right, that you can move values between to create the associations. Inlines is for inline form sets. Django has 2 of them. There's stacked ones or tabular ones. They're kind of cool for being able to handle, edit a bunch of related models. This is the only way I recommend using inline field sets. Okay, so everything that's on the left side there, that's all for your display of editing a single record. So those are all for the edit page. All the ones on the right side, I got those directions right, yeah? Yeah. All the ones on the right side are for the list page, the page where you see multiple records listed at once. So list display lets you control what fields show up. Normally Django takes your dunder Unicode or dunder str method, renders that as whatever the row is for your record, and lets you click on whatever it is that you typed in there. If you want to show other things, so we'll use a blog post again. Blog posts usually have a flag for whether or not they're published. So maybe you want to show the title and whether or not it's been published. List display will let you show the published field and the title field at the same time in whatever order that you want. List display links controls which of those things you can click on to go edit that thing. So maybe you put the published first. It makes no sense to click on published to go see whether, to go edit the thing. So you can move the link. List editable goes a step further. Maybe you want to be able to publish from that list page. So list editable, you can make the published field editable. It'll actually be a real check mark or a checkbox. You can check it, uncheck it, hit save, and it will change stuff. This is dangerous though, because Django has no built-in race condition protections on this. So if I go publish a thing and you go publish a thing or unpublish a thing, then whichever one was got in there last is the one that's right. So you have to be careful about that if you're working with multiple users. List filter and search fields help you find things. So list filter lets you specify fields that are filterable. So I want to find all the blog posts from the past 6 months. Or I want to find all the users that have a certain group as their main group, or whatever. And search fields says I want to be able to search through the titles and the body content of all of my blog posts. Give me an actual search box so I can type in, hit enter, and it'll pull up just the things that match those conditions. All of these are editable through either just attributes on your model admin or by overriding methods. So you can get really complex on your customization of these things if you want. And there's more of these that I didn't put in there. These are just the ones that you use kind of often. How many of you have been in the admin? You have a big long list of stuff. They have checkboxes next to them. You click a couple of checkboxes, go to the drop-down menu and choose delete to delete 5 things at once or whatever. So you can do bulk actions in Django's admin. The only one it comes with by default is delete, which is probably the one you're going to use most often. But to go back to blog posts, maybe you want to be able to publish multiples of these at once, or unpublish them. So you can create custom actions which take a query set, and they perform whatever action you want on them. So you've checked those boxes, it sends those 5 things off to the function, and the function does whatever the function does. So those are pretty handy and pretty cool for writing your own. And to further customize the admin, especially if you're working on client sites where maybe you don't want them to know that they're just using Django's admin, you can completely customize the templates, the CSS, everything. The global admin templates in your global site-wide templates directory, just create a new directory called admin, and you can override the templates there. Do whatever you want, copy them out of Django first so that you know what goes on in them. If you want to get really specific and customize them just for a single app, you do that in that apps template directory. or you can go even further and customize them just for a single model. That's really handy when you want to do like a live markdown preview, or you want to be able to edit images inside of your admin with like a JavaScript plugin. You can do all of that and more. Okay, anything about the admin? Did any of you see Jacob Kaplan-Moss's blog post about how much it would cost to make a new version of the admin? The estimate was around $1 million. So those of you who want to make new admins, that's what you're up against. They're awesome, though. They really are. Okay, let's talk about users and security for a minute, because that's important, right? Keeping things safe and secure. Okay, so I'm going to assume that you're using Django's built-in class, built-in user class, but you don't have to. Everything I'm going to go over more or less covers custom user classes as well. So, yeah. You can customize Django's registration flow. It doesn't really have one that's built in. The built-in user registration flow is to create a new user object in the database. That's it. You call create user, it'll hash the password, store that, and done. You have a user. So you can completely customize that all you want. You can add whatever steps in you want. And you can also look at packages like Django registration or Django all auth if you want to have shortcuts for making that better or worse. Registration gives you a whole workflow of like they have to validate their email address and stuff. And all auth lets them sign up with Facebook or whatever. So once you have users, you have to be able to authenticate them. Django's default authentication is you pass in credentials, it hashes the password you passed in, checks if it matches the database, sends you back a good user if a user exists. But Django's registration is also customizable. You can change out the authentication backend if, for instance, you want to go up against LDAP or something, because you already have a built-in system for that. That's more common in like heavily corporate environments, heavily enterprise environments, but you know, it does happen. I suppose you could authenticate against like Twitter or something too if you really wanted to. Don't do that. Once you have an authenticated user, you have to know whether or not they can do the thing they said they wanted to do, right? So if you want to come and delete one of my records, I have to know who you are, and then I have to know whether or not I'm going to let you delete that record. So if you're a super user, which you remember making a super user when you first created your Django project, right? You get to do whatever you want. That's why you're a super user. No one can hold you down. Fly, do whatever you want. You're just a super user. Super users are always assumed to have all permissions. In fact, you don't even check permissions on super users. They automatically get to do it. The next set of users, though, is called authenticated users. They're users that we know who they are. They're logged in. They're authenticated. We check to see if they have permissions based on their actual user model having permissions, or user instance, rather, having permissions, or belonging to a group that has that permission. So if you want to come delete something, I have to check and see, or Django does, if you have the can delete permission on that model. And our last group is anonymous users. We don't know who they are. Most of the time, we don't let them do anything because we don't know who they are. You let them read stuff, but you won't let them actually modify things. If you want to get further into this and you want to be like, okay, you can edit the blog post that you created, but you can't edit anyone else's blog post, which is pretty common. It's called object level permissions or row level permissions. Django doesn't do that. But there's a package called Django Guardian that makes that really easy to do. So check out Django Guardian if you need row level permissions. You can also do checks for this inside of your views or a mix-in or a model manager, but that's a lot more trouble. All right, let's talk about passwords. Hashing stuff. One of my favorite security features of Django is the password system, which seems really weird, but the more I read about cryptography, the more I like Django's way of doing it. So Django comes with a really strong algorithm already set up. It uses what's called PBKDF2, which is pretty strong. It would take people a very long time, like heat death of the universe, to actually break a PBKDF2 password with current processors. That will change. PBKDF will eventually be deprecated as like SHA-1 and MD5 are now because they're not that hard to break. The cool thing is, though, let's say it's 5 years from now and PBKDF2 is no longer really all that strong. Argon 2 has already replaced it, actually, like right now. But we've got Argon 3 at that point, and that's the new one to use. So Django ships a new version and says, hey, Argon 3 is the default password hasher. You don't have to do anything as a Django developer, which is pretty awesome. You install that new version of Django, you let it set the password hasher, which you won't have set customized anyway, most likely. And the next time your user logs in, Django goes, oh, they're PBKDF2. That's the old one. I'm going to take their new password, I'm going to hash it with that, see if they're logged in. They are. I'm going to take their password, hash it with Argon 3, and save that in the database now instead. So you've got a future-proofed hashing thing going on, which is pretty cool. I teach Flask courses every once in a while, and I haven't found anything in Flask that's that smart. And it's really sad, because I like that part. I don't like having to change people's passwords manually. And then, outside of authentication and all that stuff, Django has 3 really great features when you're working on the web, because the web is a horrible place. Those are cross-site scripting, CSRF, or cross-site request forgery, and clickjacking protections. So we'll pretend that we have a nefarious user who's trying to destroy our site, and they come to put in their comment, and they throw in, JavaScript : onClick, blah, 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 does whatever, right? If we don't have XSS, or cross-site scripting protection, their JavaScript gets turned into code that actually runs on the front end of our site, and it'll make something happen. They make a pop-up, or they make a button that goes to somewhere nefarious, or they do whatever. Django, though, knows that's a really common thing. I mean, PHP knows that's a common thing. So we automatically escape that. So their script tag, script kiddie thing where they were like, oh, I'm so cool, just turns into text on the page, and it looks really dumb. So that's fun. For bonus points, you detect that they did that and then give them a silly message. Anyway, CSRF, CSRF, cross-site request forgery, stops that same person from making a site with a domain that looks really close to yours and sending a request to your site to try to get someone else's user session or whatever. Django expects a CSRF token, which is unique to the view, to come in on every post request to that view. If that CSRF token doesn't come in, or that CSRF token isn't valid for the site that you're running, Django just rejects the request. He goes, nope, I don't know what you're talking about. I don't know what this is at all. So CSRF is great. Nobody can fake requests to your site. And the last one, clickjacking, is it's ridiculous to me that this is even a thing. But if someone was to take your site, put it into a transparent iframe, and put, say, a thing that purchases products, like you have a button that's buy now, and they hide that buy now button right over some innocuous button on their site, a user who's always logged into your site because they love to buy your stuff comes to their site, goes to click that button that looks really genuine and fine, it actually clicks the buy now button and charges them money. They never saw it because it's transparent. Django prevents that by putting in a header that tells the browser not to render your site inside of a frame. So it's kind of cool. You can turn all these things off. You shouldn't, but you can if you had to for some reason. You can also turn off some of these things for just specific views. So if you're I can never send a CSRF token to this view, you can turn it off there. But don't turn them off if you don't have to. Okay, anything about users or auth or any of that stuff? No? All right. We're not too far in from the end here. Come up with questions. Okay, this is a bit more freeform of a section. This doesn't follow a great pattern. It's just kind of me talking about some other stuff I've picked up over the years. I've been doing Django for about 8 years. God, yeah. So just stuff I've picked up. So the first bit of advice is to follow patterns as much as you can. If you're always naming your views the same way, and you're always naming your templates the same way, and your forms the same way, it becomes really easy for someone else to come into your project and pick up and figure out what you're doing. It also makes it really easy when you go back to that client project from 2 years ago, and you've got to figure out where that user login form is. Well, it's probably in forms.py, and it's probably called user login form, or user authentication form, or whatever. Don't suddenly switch names, Don't go from create_recipe to meal_creation, because you're just going to confuse yourself. You're just going to get lost. It's horrible. Wheels exist both as a Python thing, like pip install a wheel, and which those are awesome. You should use wheels as much as possible. Precompiled binaries is the best thing ever. But Django's a big community. It's over 10 years old. We had a birthday party for it last year, like literally a birthday party. We had cake. It was amazing. In Lawrence, anyway. So it's 10 years old. Chances are whatever thing you're running into that you need to solve, some problem you've come up with, some site you want to build, someone's built a package that at least addresses that, if not actually solves it. So look through what the community has offered. The community has a huge amount of amazing things. I mean, I've only talked about large overview projects, like areas of projects, and I've recommended like 5 packages to you already. So there's packages for everything. PyPI is huge if you've never explored PyPI. So if you want to do caching, look at Johnny Cash and other caching. Actually, Johnny Cash I think is old now, sadly. Best name ever, other than Jimmy Page, which was a page caching thing. But yeah, look for packages for that. If you want to do REST APIs, Django REST framework takes out like all of the work. It makes it so awesome to do. Yeah, so look for packages that already do things. Speaking of caching, cache things. Put as much stuff into a cache as you possibly can. Every time you fetch records from the database, put it in a cache. When you render a template, put it in a cache. This won't matter while you're developing. While you're developing, ignore caches. When you go live, though, caches are amazing. Caches get rid of all the work that Python has to do and all the time that's associated with that. So do that. Same thing with like static files. Instead of having Python serve your static files, put them in a their own database, not database, their own server that serves just them, or put them into like a content distribution network, stuff like that. Remember that thing? Yeah, use that thing. That thing's amazing. It solves a ton of problems. It'll even show you emails that you send from a view without actually having to go look at the email. Like, it's so cool. It's awesome. Don't repeat yourself. Dry. It's not a hard and fast rule. It's fine to repeat yourself, especially while you're learning, especially while you're first developing something. Repeat stuff constantly. It's cool. But try to make sure that in the end, before you deliver a product to someone, or you put a website online, or you release a third-party package, whatever you do, go through and check to make sure that if you've done something 2 or 3 times, you've pulled that out into a new function or a new class or a new module so you can use it again. Because odds are, as you keep building on that thing, or someone starts building on whatever you've worked on, they're going to need to do what you've already done as well, and that way they get to use it. And when you're doing testing, you only have to test one thing instead of testing the same implementation 3 or 4 times, right? It's nice to only have to do one thing. Speaking of, write tests for everything. Test your views, test your URLs, test your models, your forms. The cool thing is you can test URLs and views at the same time. People here will tell you not to do that. I tell you to do it because you're lazy and I'm lazy. It's fine. Basically, when you hit a URL, it renders a view. So just check the URL and check the view. One test. Got them both. Still, test. Test as much stuff as you can. Okay. Any questions about my random advice section? Yeah.
In reference to caching rendered templates,
Mm-hmm.
what's the best way to go about that?
There used to be a package called Jimmy Page, which one of my favorite package names. And so whenever you would render the page, right, you have that HTML, it basically would record like what the URL was and what the rendered output template was, and like context variables, whatever, so if it's user specific. And it would store that into like memcached or Redis or something, so that the next time those conditions are the same, it just pulls it out of there, assuming it's not too old. You can set up things like varnish to do that as well, where it just kind of holds on to like a copy for a little while. So the user gets it out of that cache instead of actually going to Django. Varnish is way beyond my expertise, so I can't really tell you how to set that up. But Varnish is the thing to go look into for caching. But if you can cache like database queries, which is pretty easy and pretty common, then page rendering isn't usually your bottleneck. Usually your bottleneck is going to be your database. Databases are usually the slower part, or anytime that you're hitting the hard drive. If you can avoid those two things, then you'll save a lot of time. Python executes fairly fast. I mean, it's not C, but it's pretty quick. And sending things over the wire through HTTP isn't really that slow. Most of your problems are database and actually compiling the template, because it comes from the disk. Any other questions on this stuff? Okay. So I've given you a lot of stuff. There's been all sorts of areas and suggestions. I have more suggestions. Okay, so let's talk about learning. Maybe you're pretty new to Django or pretty new to Python. You want to go learn more, or you want to learn other languages or these weird things like caching or whatever. There are lots of places to go online to learn stuff. I'm a big fan of Treehouse because I work there. But Coursera, Codecademy, Udacity, and Udemy have a ton of Python content and Django content. YouTube has a lot of it. Go Django is pretty cool. Guy named Buddy, who is here at PyCon, he runs that. You should find him and talk to him. And then there's also books like Learn Python the Hard Way that's all online. And I think Automate the Boring Stuff is all online as well. Those are really good to read through. And the official Python and Django tutorials and the Django Girls tutorial. Those are all excellent to read through if you're like even a little shaky on Django. They're great resources. Speaking of books, there are a lot of books out there. Django Unleashed is a really great book by Andrew Pinkham? I'm not going to say his last name. By Andrew. It just recently came out. I've heard really good things about it. I haven't gotten to read it yet myself. Python Crash Course is a really good introduction to Python. It will actually teach you how to do GUI stuff as well and how to do Django. Python Crash Course. It's by No Starch Press. They will be here in the expo hall. They will probably have copies for sale. They also published Automate the Boring Stuff, which is a pretty cool book by Al Swigart. Two Scoops of Django, which is by Audrey and Danny Greenfeld, is a great book if you're okay with Python and Django, but you want to go a little further into customizing and just making it your very own product. That's a great book to check out. And Hello Web App, there's two versions. There's a basic version and an intermediate version by Tracy Osborne. Both excellent books. She's also here at the event. And Danny and Audrey are here too. Actually, except for Andrew, all the authors I mentioned are at PyCon. So hunt them down and talk to them about their books. And then, of course, I have one coming out, but I can't say if it's good yet or not. And then find groups. If you have a local active group like PyLadies, Django Girls, or just Python Meetups, a local Python user group, go to them. They do awesome stuff, and they're a great place to ask questions. Boot camps often do like open Q&A nights or project nights. Those are pretty good places to go talk to, or local code schools. Like here in Portland, we have the PDX Code Guild, and they do every Monday night, they do the Flying Circus, which is like a learning night. You can go and just ask questions or show off your projects, and they'll help you with it. And then they're starting a thing on like Tuesday nights for an open source project, but I don't have details yet. If you can't do those, then look online. Twitter has a lot of active conversations about Python. Facebook has a really good Python group and a really good Django group. IRC is a thing if you still remember how to use IRC. And also, there's a great group called Code Newbie, which is mainly just a Slack channel, but they have channels or rooms inside there for all different languages, and they have about 4 weekly virtual meetups that they do online where people can show off their work or ask questions, get help, whatever. So check all of those out. Code Newbie especially. And then let's talk about some other packages you could use. Maybe you don't need groups and you just need packages. Okay, so cookie cutter Django is pretty cool. It's if you've used Yeoman on the front end side of things, on like the JavaScript side of things, cookie cutter Django is kind of similar to that. You basically go, hey, I want to make a new Django project, and you'll answer some questions about what you want the project to do, and cookie cutter Django will create the project for you and install packages and set them up in installed apps and do all this nice stuff for you so that you're ready to go and just start working on your actual code. You don't have to research all these things. It's all time-tested stuff. That's also by Audrey and Danny, who created 2 scripts of Django. It's the largest woman-run project on GitHub at this point, like most starred, which is pretty awesome. Django REST framework is a framework that sits on top of the Django framework to turn your Django models into RESTful endpoints. So you can take your models and immediately serve JSON or XML from them, which is pretty awesome. It's by a guy whose name I can't think of right now. But he's trying to go independent, which is kind of cool. He's currently looking for people to sponsor his production of Django REST framework, because it's used by a lot of big companies. So it's kind of cool seeing somebody like turn their open source project into a full-time job. So that's kind of neat. Django braces, which is my thing for class-based views. If you do class-based views, I think it's pretty handy. I'm biased. Django debug toolbar, 3rd time I'm bringing it up. I hope you're noticing a trend. It's one you should be using. And you should be testing. You have no excuse not to test. Django's testing framework uses the unit test framework that Python comes with, which is a very sensible choice because it's always there. It's not that hard to write test cases for Django. They're pretty easy. But if you're writing a lot of them, it can become kind of boring to keep repeating that boilerplate code of like extending unit test, test case, and writing def setup and all that stuff. PyTest is a really great version of testing in Python where you just write functions for each of your tests. There's no overarching class. There's nothing like that. You just write functions. So def, test, whatever, do your stuff. So if you're writing a lot of tests, PyTest is a pretty good way to get into that. There are some plugins for PyTest that make it work better with Django to do like automatically setting up your models and your test database and stuff. So check those out if you go down that road. Coverage.py. Doesn't do you any good to write tests if you don't know that you're actually testing something and what you have left to test. So coverage.py, if you've never seen it, is one of my absolute favorite packages. It will tell you which lines in your files have not had tests written for them yet. So you can find out, hey, I tested everything in this file except for that one giant method at the bottom. Or I forgot to test what happens if a user isn't logged in. It will test branches, so every time you make an if, you should have 2 tests, right? One for when the if is true, one for if the if is false. And it'll tell you when you've missed those. I don't know if it's built in or if you have to have plugins for it now, but there is a way to have coverage.py also tell you which parts of templates have not been tested yet. So if you put logic into your templates, you can now test to make sure that that logic is sound and tested. And if you're writing tests, you often need a lot of data. Django's way of solving that is called fixtures, which are giant files full of text that get loaded into the database. The bad part about fixtures is they get stale, they get outdated really quickly. Every time you change your model, you have to regenerate your fixtures, which means you have to put more data back into the database and then create fixtures again. Fixtures are kind of horrible. So Factory Boy, and there's another one named Model Mommy, which I didn't put on there because I can't say the name and stay serious. They will do factories for you for your models. So for instance, with Factory Boy, you set up a user factory, and you say the users have a username, they have a first name, they have a last name, they have a password. Make users for me. And you can tell it to give you 15 users, and it will randomly generate 15 users and give them to you, and you can do whatever you want with them. Model Mommy works the same way. Kind of your choice which of those you use. I think Factory Boy is a little bit more developed. Like it's had a bit more work done on it, but they're both pretty good. Okay. Yeah. Mm-hmm. Mm-hmm. So can Django REST framework handle XML form, like sending back XML? Yeah. I do believe out of the box, you pass in like question mark format equals XML on the request, and it will automatically send out XML instead of JSON. And I think there's plugins you can put in that'll make it do YAML as well, but I don't know why you'd want to send YAML out. Like, YAML coming across the wire seems weird. I'd rather have JSON or XML. Django REST framework has almost become its own thing like Django. There is a ridiculous number of packages on PyPI when you search for Django REST framework. So if you want to further customize that output into other formats, maybe you want to send, message pack or something, check for plugins, because there's a ton of them to customize how things come out. And I know you can customize a lot of that functionality yourself in your project, but I would check packages first. Okay. So you can always find me if you have other questions. But until then, this URL is not the slides. That is the survey that I'm supposed to ask you all to fill out about the talk. I'm happy to stay and answer any other questions, but that's that. Oh, and all my icons are from the icon project. I have to say that because I'm not paying for the icons. So you have to give credit, you know. I will have the slides online later on, internet, but I don't have them yet. And I'll send out an email to everyone with the address of those. Yeah, questions?
Can you just briefly give an overview of like when you would want to use Flask versus Django?
Okay. So when would you use Flask instead of Django? Flask is a great framework. It really is. It's just kind of a different mentality than Django has. Flask seems to be a little bit more towards like the Rails mentality of like, I'm going to pick and choose the pieces I want. It's similar to like Pyramid in that way. And this can be really great if you know what you want to use, right? If you already have a pretty good understanding of the ecosystem, you're like, yeah, I love SQL Alchemy, and I love this form library, and I love this template renderer, and I love this thing and this thing. Flask is amazing for that because you can just plug those things together, make it all work, and build your site. Personally, I don't care to research packages that much. I kind of like having those choices made for me. So Django's generally a little bit better for that. Django's a little bit more like, here's all your batteries, it all works. I see you. And so usually for me, like I'll use Flask if I want to build something that's really lightweight, something kind of, you know, a pet project or just experimenting with an idea. And I'll generally use Django when I have something that like I know I need heavy database access. I know I need, you know, a lot of power without having to do a lot of the work myself. Because as a developer, I'm very lazy and don't want to write a lot of things myself. So yeah, most of the time I'll play with Flask, but Django is like serious work. And that sounds really dismissive of Flask, and it shouldn't. Flask is awesome and can build amazing things. It's just not my preference for building those things. Do you have something to add? Or did I cover it?
Flask is fast, doesn't scale because whenever you make big things, you have a lot of requests going back and forth and a lot of line views.
I can see Flask falling flat with enough of a load on it, but being as mix and match as Flask is, I'm sure that can be mitigated as well. You could most definitely build a giant thing in Flask. You would just have to take the proper steps to get there. And Flask not making any of those decisions for you means that all that work is on you. Pyramid and Django both do a little bit better job of kind of hand-holding your way into having a stable system. So, yeah. Did you have a question?
Curious, got any good, like, more examples of use.py and urls.py? All the examples I look at online are like simple, like 1 or 2 lines.
Mm-hmm.
Whereas most web apps might have, 20 different base URLs or something. You might have a store, you might have like a utility, you might have a quote. Everything I see called it just like view. They can't all be named view, obviously.
No, you wouldn't want to call them all of you. I mean, you could. You could totally call them all of you. But you probably don't want to. Let me see what this thing is. Like, I'll have to just look at my code and see what I have. Yeah, so like these are I probably shouldn't even be showing this. These are views for the book that I'm writing that are purposefully not using some of the features of Django. So ignore the fact that some of these things are done really stupidly. But so like, for instance, here's an upload image view, right? So we have this one here. And so we have the request that comes in, and we check to see what the request method is. So I'm checking to see if it's a post or if it's a get. Well, actually, a post or anything else, because anything else I'm going to treat like a get. So if it's a post, then I instantiate a version of the form. I'll move the mouse there. I instantiate a version of the form, and I fill it with whatever data comes in through the post, and I fill it with whatever data comes in as binary files, because it's a a multi-part form, rather. So it has text, and then it has files as well, right?
So it's function-based.
Yeah, this is function-based.
So what is your URLs file?
That should be this one. So right there, because that's the default view. So that one's just empty. But so like for edit, we just toss in edit. Like I said, this is the very beginning of the book. There's not anything super complicated here.
So views is the directory of edit images, file directory?
So what we're doing here, this is really common in Django, is we're saying from the current directory, which is what the period there is for. So from the current module, import a file named views. And so then inside of views, I have methods. So I'm just accessing those as attributes of the views module that I'm on. So now they could totally be their own files, but then I have to do a fun thing with a init.py and stuff like that to make them look like they're attributes of the larger thing instead of being sub things, right? But yeah, I mean, most of your views really don't vary that much, which is why we have things like the class-based views, because you do fall into patterns where you're doing the same work over and over and over again. So why are you typing that out repeatedly when you don't need to? I don't think I have anything handy to show that isn't, or that is class-based. Let me find out. We can browse through Kenneth's computer and see what's in here. I don't know what any of these things are. There's a test site inside here. So like these are some class-based views that we're testing. So we have, that we use for tests rather. So we have this OK view, which just inherits from view. And each of these just basically returns like, hey, things are good. So then you can see like we make other views that have the different mix-ins applied to test and see how they work. So this is what your views end up looking like when you're doing class-based views, is you have your inheritance tree, whatever mix-ins you're using, and then your actual final view, which your mix-ins always go on the left. You want your mix-ins to come before your concrete final class so that whenever Python's trying to find where a method or whatever comes from, it knows the chain to look through much more cleanly. And then you end up defining just a few methods or even just a few attributes, and that's it. Like class-based views, the code looks incomplete because there's so little of it, but they do a ton. And if you were to look at the URLs for this, they end up just looking like that, right? We import the views thing again. I can't even see what's up there. Anyway, we import the views again, and then you see we use like views dot whatever the name of the class is and dot as view, just over and over again. I wish there was, like, this is kind of the one complaint I have about class-based views in Django, is that you end up typing out like whatever dot as view just repeatedly. It would be nice to not have to do that, but it's not that big of a deal, and you're being explicit as you're supposed to be with Python. So I can't really complain because I like explicitness. But here you can see like capturing a variable. So like here we're going to capture one or more digits, and we're going to call those pk. Or here we're going to capture one or more digits, call it pk. There's going to be a hyphen, and then we're going to capture one or more word characters, which is anything that Unicode recognizes, and hyphens, and we're going to call that slug. So this is harkening back, whatever the word is. This is going back to Django's history as like a newspaper publisher, because you would have a slug for a story, a short little phrase or word that identifies the story, and that way you could reference it quickly. It's surprising how well that translates to blog posts or product names or menu items on a restaurant site or a username. It all works out as kind of the same idea.
So name in that context, what?
So name here is what the view is called when we're referencing it through the reverse method, or the reverse function. So reverse is a function that Django provides that you can give it a views executable, or you can give it a name, and it will go figure out what the URL is for that thing. So if I have, in this case, if I tell it to look up canonical slug, and I give it a PK of 2 and a slug of football, then I'm going to get article-canonical/2/football/ when reverse gets back to me and tells me what it's going to be. So reverse is how we go and look up stuff. Now these probably have a namespace on them. Actually, they don't. That's another file. Because I remember us doing this and thinking it was weird. So these are in namespaced, so you would have some sort of name, like articles, and then colon, and then namespaced article when you're trying to reverse it. So namespaces let you repeat URL names in different contexts. So in this namespace, create belongs to recipes, and in this namespace, create belongs to meals, and in this namespace, create belongs to exercises. But they're always called create. They just have a namespace in front of them. That's a good thing to learn how to do because it makes your URLs a lot nicer named. You can shorten those names a whole lot and put stuff together nicely. All right. Any other? Yeah.
My question is, if my project is not really a web activity, it's actually just a bunch of cron job to make some batch job do the data processing, use the EL, and so on, and then so in this case, using Django is over-engineered or something incorrect.
So your use case for Django is that really you're just running cron jobs that run bash commands.
Yes. Correct.
I mean, I guess it depends on if you need to create like new cron jobs and bash things through a web interface, in which case, sure. I mean, you're just using forms and writing stuff. But if you're more looking for like, I want a Python solution for scheduling cron jobs, Celery is pretty amazing. Celery is a task queue, more or less, where you go, hey, here's a whole bunch of jobs I want you to do, and Celery does them in order and tells you what happened, right, whether or not it succeeded. The cool thing about Celery is you can have it just run things on a cron. You can be like, hey, every hour run this method, run this function for me, and Celery will do it. So you don't necessarily need Django unless you need a web interface. But Celery is a great Python way to have cron jobs running like kind of on demand. Celery and Django also work really nicely together if you have batch jobs that you want to be able to tell users when they're done. Like they upload 100 images, you're going to process them all and tell them when they're ready to view. Celery's awesome. Yeah. Celery is spelled just like the vegetable, yes. It's named after something from the Ruby world, but I don't remember what, and it's not lettuce. Yeah, maybe? I don't know. We have a problem with silly names in the programming world. I mean, I say problem. I love them all, but they're silly. What was that? Yeah, big time. Yeah. It gets really hard every once in a while to like recommend a package to someone because the name is just ridiculous. But oh well. It's programming. All right, any other questions? I should have padded this out with more slides. Anyway, yeah. So, yeah, you got a question?
It might be off topic, but
Okay.
is there
Is there a way outside of admin for users to bulk import information? Do you want to do it through a web interface, or do people have access to the server?
Like importing a CSV for a bunch of data
Mm-hmm.
and putting it in the database.
Yeah, I mean, you would have to write it yourself, but you can totally give them a form with a file field in it. File fields accept uploads. So when they upload the CSV file, then use the CSV module or tablib or something like that to process that. The default model manager has a method called bulk create, where you pass it a list of instances. The cool thing about lists is you can use list comprehensions to make them. And so then you can do a list comprehension that creates all your model instances without actually saving them to the database. And bulk create will insert them all with a single query. It doesn't tell you, like, it doesn't, you know how if you use like model.objects.create, it sends you back the thing that was created. Bulk create won't do that. And I think it has an upper limit on how many records it can create at once. I want to say it's like 100 right now. It will do as many inserts as it needs to get through all of those things, but it does them like 100 at a time. But yeah, bulk create will create things in bulk. So it's a really good method to use. Yes?
Celery, and Django Celery, the example you gave of letting users know that something is completed.
Mm-hmm.
Is it a non-standard use case to have Celery used as something to say process log files and put those into the database? We don't need to let users know necessarily, but just to update the database automatically.
So is it non-standard to have Celery do something that you don't tell a user about?
Or
To do something like behind the scenes?
to have Celery do something that a user would normally do.
Oh, no. I mean, Celery's goal, Celery's purpose is just to handle these task queues, because task queues are really irritating to build, on your own. So you can have Celery working behind the scenes and doing things users would normally do if you can automate that. And you don't have to tell anyone. It's generally a good idea to have some sort of dashboard letting you know if Celery has successfully done its work, because occasionally you will get jobs that hang, or a job load that's just too big and Celery like freaks out and doesn't know what to do.
That into one of the reports, you make a view for that.
You can make a view for that. I want to say there's a package or two that will just give you a Celery status page and let you know like what jobs are running and if they're done or not. But yeah, I mean, and it's also a thing you could easily build into the admin. You could add a new admin view. I say easily enough. You could add a new admin view that just tells you the status of your Celery jobs. And so then you're like, okay, cool, job 125 got hung up. I need to go and look at the logs for that. There is a thing you have to turn on in Celery to get that reporting, and I don't remember what it is off the top of my head. Yeah. Yeah, you can use the SQL backend, and you can also store things into like you can use like a Redis backend that will just hold on to your jobs and tell you if they're completed or not, which is a little bit faster access than SQL is going to be. Redis is a much faster throughput. But yeah, you basically just store that in a database whether or not it was good. And I think you can also have Celery send you like a notification if something goes wrong, like through Twilio or something, if you really wanted to. All right. Well, thank you all. Lunch is in about 40 minutes, 50 minutes upstairs where it was yesterday. If you were here, if you weren't, 2 flights up, you'll smell the food in the Oregon Ballroom. And like I said, I'll post the slides online later. And if you have questions, just come find me.